In section 12, we'll be taking a deep dive into another specific type of function called the quadratic function. And the quadratic function falls under a bigger umbrella of a function type called polynomial functions. And we've already studied two specific types of polynomial function. We have studied the degree 0 as well as the degree 1 polynomial. The degree 0 polynomial is called the constant function. We saw that on our parent function list. And the degree 1 polynomial is the linear function, which would be the identity function from our parent function list. We've spent several sections looking at not just the basics of the linear function, but also some of the applications with the linear function, talking about linear systems, talking about rate of change, difference quotient. So remember, the constant function was the horizontal line whenever it's graphed. So that would be an example of a constant function. And then for the linear function, it was all things that were straight, but also would be at some kind of angle, something like this. Now, technically, the constant function is a linear function because it is a straight line, but it's the most basic type of linear function, so it does have its own special name. So looking at definition 12.1 is going to tell us a little bit more about the quadratic function. The quadratic function is a degree 2 type polynomial. Now, where these degrees come from is the largest power of the variable that shows up in the equation. So for example, on the linear function, we expect the equation to always be of the form y equals mx plus b. So the x has an implied power of 1, hence why we call it degree 1. Whereas in the constant function, when you have something like y equals, let's say 3, just to give a specific example there, you'll notice that there is no variable. And so the variable would then say to be having a power of 0. So that's why we call this a degree 0 equation or degree 0 polynomial. So number 2 tells us the standard form, that should say form, not from, standard form of a quadratic function represented as an equation is given by, and then we have two different representations for the quadratic equation. The first equation, the first version of this right here, this is going to be more geared toward a generalized polynomial type notation. We'll talk more about this type of notation once we get into the section on polynomial. There'll be 3 sections. I believe it's 13, 14, and 15 that'll be coming up. What I want to focus on is this version of the equation right here. This is the one that most students are familiar with, ax squared plus bx plus c. A, b, and c are all going to be real numbers, and these are going to be constants. And in order for us to make sure that the function is quadratic, you have to make sure that the a value is chosen to not be 0. So as long as you do that, you can make any quadratic function that you want. In the next example, we'll see a chance to actually make one for ourselves using this definition.